welcome to my workshop. This is Roger Clyde Webb here from the Australian Inventors Workshop. Today we're going to make this 3500 lumen phenomenally bright LED flashlight that's actually quite a sensible unit. It has 3 settings, so that's 3 different power levels, and so with the batteries inside it will last up to 12 hours. If you have it on maximum brightness, about 2.5 hours. So it's a well worth making project. In fact, it's an easy project to make, minimal tools, and I think mum, dad and the kids can actually make this together. There's something for everybody to do, and I hope you like it. One word of warning though, it's a fairly lengthy video, so grab a cuppa, sit down, relax and enjoy. Welcome again to my workshop. Today we're going to do something completely different. We're not going to do any CNC work or any wood turning. We're going to do a project today that mums and dads and the kids can actually all get involved with. It's not too difficult to do, and you'll also need minimal tools to do it with. What we're going to do is make a star blaster light. What I would regard that as is a useful, very powerful torch that you can really do something with, that you can make at home. And what we're going to do, we're going to make it out of LED downlights. Each one of these is 500 lumens, or 500 lux, whichever way you want to call it. 3 of these is equivalent to the old 100-watt incandescent light that you have in your house. So we're going to put 7 of these in. So that would make it 3500 lumens. Very, very bright. So I'll take you now and show you what you'll need to do this. Okay, for this project you need to go along to your hardware store and pick up about a meter of 100mm sewer pipe, actually, a threaded collar, a threaded cap, and you'll also need an expansion collar. Other tools you'll need is a set of small files, a couple of intermediate files, soldering iron, solder, some electrical tape, a couple of screwdrivers, pointer nose pliers, a pair of scissors, most importantly glue gun, LED downlight 12 volt. Okay, that's the ones with the little pins like this. I bought several packets, but we will need 7 for this build. Now, specialized electrical stuff, you need 2 to 3 on-off switches DC. And you'll get these from your car accessory shop. Okay, a very small 12 volt switch, a large 20 amp 12 or 24 volt switch, and what's most important is a rocket launching button. Now also, in my particular build, I am going to put a 12 volt computer fan in to keep the LED light bank fairly cool. You'll also need a piece of aluminium plate. This can normally be bought from a hardware store. Other tools you'll need is a set of drills, a hole saw that's the correct size for your LED light, and a cordless drill. The power source for this ultra bright torch, you can go to your local radio control shop and pick up these nickel metal hydride recharge. After you've cut out the holes in your aluminium metal sheet, it's necessary to clean off any burrs or any rough edges because you don't want to damage your LED light fittings. Place your aluminium plate over your LED light fittings, ensuring that each LED light fitting has their terminals set in a row so as it makes it easier to fit the electrical cables to, and then apply hot glue to the surrounding outside between the aluminium and the light fitting to adhese them into place. Okay, and the end result should look something like this. Once you've got the glue gun nice and hot, just get your threaded sleeve, put over the end of the one end of the tube, and just run a bead of hot glue around You need to get 3 red wires and solder them to one terminal on each of the 3 main on-off switches. Next you need to make a bit of a daisy chain. Choose one terminal of each of the downlights. So it'll be this right hand one here to this right hand one here, and make 6 leads, short leads like this. So the last one, you have a piece of black wire that's about 500 millimeters long, and you solder it to 2 shorter pieces of wire to make a bridge which goes to the center one and this one, and it forms a chain and joins each of the 1 single pins up all together, because this is the earth return. This is a DC current setup, not AC, so it's DC. Okay, this next step might look complex, but it really isn't. I want to be able to have connected up or switched on together, first of all, the middle one on its own, then 3, 1, 2, 3, and then 1, 2, 3. So what I've done is the black leads, okay, this is a common earth or negative. So I have one switch here with this red lead connected up to this single pin here, which means when this is switched on, only this single light in the middle will come on. Now then, whereas this switch with a single lead coming out of it is soldered onto this terminal, which is linked to this one and this one. So that means when this switch is switched on, these 3 will operate, will come on, and so on and so forth for this 3rd switch. So I have a means of independently switching groups of 3 or a single on in combination with each other. to save power, and it means I don't have to have the full amount of light on all the time. If you just run the center one, that will, give us more than 12 hours of light. Okay, so what you do, you get one quite thick lead, heavy gauge cable for DC current, and solder three into a group, and then one of these three to each of the switches. 1, 2, and 3. And then a fourth little feed wire that goes to the switch, which is soldered onto the switch like that, that goes to the fan. You will also notice that I've given all the plastic components a gloss black paint finish. It's my preferred paint color for something like this. Torches are normally black. So the next job to do is to fit the light cluster into the housing. So to do that, it's necessary for us to take all of these wires and switches and feed through. Very simple. Feed them through. Like so. Then it's going to be necessary for us to run a bead of hot glue around here, around the edge, to fix this in and seal it all up. It's also a very good idea at this stage to check each individual switch to make sure that indeed it is connected upright and all the switching is correct. Okay, we're at the point now where we need to put all the switches and the wiring up into the main housing, so it's necessary to undo the retaining nut off the switch, taking the retaining nut off and the on-off direction, and the backing nut here, it's necessary to wind all the way down until we meet the screws here, because then that will give us sufficient material to go through the plastic. Right, we're at the point now where I've put in the computer fan for the cooling, and I'm just using a little bit of hot glue just to hold it in place. And then the next phase is to, you'll need to put some insulation tape on the cables here to stop it going into the fan, but feed it up. I fitted these little connectors so I can have somewhere to push the connectors in here, and I connect directly to the batteries to enable charging to take place. Making sure that the red wire goes on the red terminal, otherwise you're going to be in trouble. So the battery should be a nice firm fit inside so they don't slide around. So to recap, the 2 earth leads here are connected into this terminal. So we have the earth lead from the fan, earth lead connection to the battery charger, and the earth lead to the light cluster up the front. This positive lead, okay, gets connected through the switch, and this goes then to the light switch cluster up here. So now we can connect this one. It's a good point now to test it. Fan. Idea is when you're putting the cap on, wind it backwards, okay, at least 2 turns, so when you put the cap on, the cable's already wound up backwards, so then when you wind it forwards, if I can get it on square, it doesn't tangle the wires up and rip them off. And there you have nearly finished torch. All I've got to do now is to clean up this glue around here and maybe put some finishing touches to it. So there it is. Power up, fan on, 1, 4, 7. There it is. Weighs approximately maybe 1.5 kilos, maybe possibly 2 kilos. So I hope you've liked the making of this phenomenally bright giant torch, which really is a sensible torch, because with the power settings that it has, the single, 4 or 7, which gives a total of 3,500 lumens, you know, you can use one 500 lumen globe, and that will give you between 10 and 12 hours of light. If you use them all, you still have approximately 2 to 2.5 hours of light with the lithium-ion batteries that I've got in the back here. All the cost of this, I suppose, the most expensive part, obviously, the batteries. You could probably build this for about less than $150, which is about, what, £80, something like that? I'm talking Australian dollars too. I hope you've liked the building of this super torch, or starbuster, whatever you want to call it. If you have, please press like and subscribe to my channel. That's a really good thing. On this channel you'll see me building things like this, toys, using CNC routers, wood lathes, 3D printer, even building a 3D printer as well, and different shop jobs that I do around here. And in the future, I do have a tech toy section in my YouTube channel, and I'll be doing a few more things like this, interesting things that maybe the whole family can get involved with. And it's not high tech, it's very, very low tech and safe. It's battery. So there's no mains power to be worried about. So anyway, I hope you've liked this video today. So from me now, it's bye for now.